where we're at. That's the homework. Now don't forget, if you didn't do part of the homework, you know, you can still hand in the missing part, and only that part has a late reduction. If yeah, whatever. If you see, as I went over this, you see a missing part, like someone may have forgot to do the maximum backload or something. Get it handed in tonight. I'm posting the answer tonight. Get it in your own handwriting and hand it in, and that's the only part that would be late. If I hand something back to you and it says missing something, you can still hand it in. You can hand in the original one I hand back, so I understand why you're handing it back into me. Say, hey, you had some missing parts written on my assignment, you hand it back, and here's the missing part. And I'll give you back partial points. So, it's not if you got something wrong. That's if you're missing it. If it's not there, you forgot it or whatever. So today, chapter 1, let me just go, let's review these list of subjects. Formulating equations and break-even equations is all today's, that's a big part of today, is break-even equations. Going back to, you all have accounting 201, probably 202 already, I'm thinking, at least. So break-even, we're going to talk about that. Then, this is your first introduction to truly linear programming. 4 chapters of linear programming that all build up to the 4th chapter. And here's your initial, you're going to learn 3 parts of linear programming: objective function equations, decision variables and what they're all about, and constraint equations. These are the big deal. And then hopefully we have time to do Excel. If not today, we're going to do it on Tuesday next week, and then we have a quiz. Real quick, the chapter we end just before a quiz, I don't assign homework because I don't want to bog you down with homework when you should be studying for the quiz. This is 2 days later. So there'll be no homework for chapter 1. There will be an in-class assignment though Tuesday, but no homework. You just focus on preparing for the quiz 2 days later, okay? So that's what you should expect. Is that why people aren't here? Because they know we're studying a new chapter and they know there's no in-class assignment. So we should have in-class assignments every day. No, you don't like them? I thought they would help keep your grade up. Okay, here we are. You ready? I'm on slide 28. All that stuff before that, you read before you got here, or you're going to read over the weekend, or who knows what. All right? Here's a company called Nolan Plastics, produces a line of cell phone covers. Their best-selling cover is the Viper model. It's slim but very durable, black and gray plastic cover. Several products are produced for the same manufacturing line. Here we go. Same manufacturing line, which means if several products are produced, they shut it down, retool it, redesign the line for another product. They do a certain amount, they shut it down, retool it, redesign, go back to maybe one of the other products or a different product. And that's how it works, because they invest so much money on that machine, they want that thing running every day, so they try to sell whatever it can make. They have their salespeople out there saying, hey, we can do this, and they get a contract, and now that machine's making another item. In any business I went to that was manufacturing and had a machine involved, it was all about the idle time. For them, idle time, that machine is doing nothing, but yet they're still paying for that machine because they had to get a $1 million loan to get it, is money out the window. It's opportunity cost. They want that machine running from the time the line starts to the time the line ends every day of the year that they're open, that they have workers in. So, several products are produced on that same manufacturing line. The setup costs are incurred each time a changeover is made for this new product. Suppose that the setup cost for the Viper is $3,000. Here we go. So there's $3,000 to set this up, to make these Vipers. No matter if we're only making 100 or if we're making 10,000, there's that cost that we have to incur no matter what. $3,000. That's a big setup cost. This setup cost is fixed, and it's incurred regardless of the number of units that are eventually going to be produced. In addition, suppose the variable labor and material is $2 for every one unit. For every one of these little vapor covers that are being made, and then goes to the next one who gets it into something to get a coating on it, and then someone's putting a label on it, or design, or doing something to it. That whole process involves $2 for each unit made. So we got $3,000, plus we have this $2, but I got to represent something that represents, however we're going to make. So I'm just going to use the variable x, And this pretty much is our cost equation. That's what you're looking at, the cost equation. It's all the costs involved in making this one product, the Viper cell phone cover. The thin, durable, black and gray cover. This is a fixed cost. Because maybe we're only making 10, we still got to pay this. And then 2 times 10, $20. We're making 10,000, we're paying 3,000. But 2 times 10,000 is another $20,000.
Do we need to write down like what X represents?
If you want to. If you're formulating an equation, you definitely have to represent it, what the variable represents. Because when we get to decision variables, linear programming is all about, after you read the story, you say to yourself, what's the decision that has to be made here? And then you take what you just decided the decision to be made and designate it as a variable. X equals the number of, let's say this is going to be a production problem eventually, how many we should produce. X represents the number of Viper cell phone covers to be made. We got such a large order in though, we can't make them all ourselves. We had to subcontract another, is it plastic injection? Are they using plastic? It doesn't say. If it's plastic, they're probably using what's called plastic injection machine molding. And they have to subcontract another plastic injection manufacturing company to make the ones they can't make themselves. You need to know how many they're going to be making, so you now have Y equals the number of Vapor cell phone covers, whatever word you want to use, made by someone else. Meaning you have to buy them from them because you're sending them all the specs so they can duplicate the exact process you're doing so you can fulfill the customer's order. Manufacturers do this all the time. When they get an order large and they get to realize, wow, we have a deadline to get this to the customer. We told them we'd have it to them in 4 weeks. No matter what we do, we can't make this ourselves and meet that order. They start scrambling to find a subcontractor to subcontract out the additional amount. So it may cost us $2 for each one we make, but we have to pay like $6 for every one we get from the subcontractor. They're incurring this overhead in their setup now, and they're incurring all the labor, and they're adding on to make profit. So do we want to try to make as many as we can, or buy as many as we can from the subcontractor? Because it's only $2 each one, but we got to incur this, so it kind of makes it a tough decision. If there's only a few to be made, we can do it ourselves. If we subcontract it out, then we avoid that $3,000. It all depends how much we're going to get for the contract, how much above the $6 each. But in most cases, you always want to go for whatever the decision is that will be the lowest cost for you, which would be making it ourselves, as long as there's enough of the order, big order. So that $3,000 is a fixed cost. That $2 for each one made is a variable cost. The costs combined are the total cost, depending on how many you're making. Next, the slide says, we're going to sell these, and okay, here's the equation. Cost equation, 3,000 plus 2x. Hang on. We're going to sell these things. Is this it? Does it tell you how much we're selling for? Is it back here? Did I mention this is a new PowerPoint? This thing says. Are we recording this? Can I edit this out?
It's on the next one.
It's on the next one, that's it? See, if there were extra credit, but there's not. Suppose we're selling these for $5. Okay, we have to pay $6 for the subcontractor. This is crazy. Now we have to take into consideration, in order to complete this order, in order to accept it, we would have to lose $1 on each one. This is a very common thing. And for a lot of companies, even if they lose $1 on each one, as long as they don't have to send a whole bunch of that subcontractor, they'll go ahead and eat that $1 to fulfill the contract, because the profit for the ones they're making are so large compared to the $1 loss for each one there, they still go forward. So we're selling each one for $5, and that's all we're told on revenue, $5. And we get $5 for each one, the same X. Because however many we're going to sell for $5 is the same amount we're going to make with a variable cost of $2 and overhead of $3,000. So that X is the same X. Now, revenue minus cost equals either profit or loss. To turn this into a break-even problem, you set the equation to 0. There is a break-even now. So I have 5x minus, putting this in parentheses because this all of this added together, 3,000 plus 2x, 5x revenue minus all our costs, 3,000 plus 2x right here, equals 0. Now you just use algebra, you get the x all by itself to figure out what it would be to get to break even. If you have a target profit, I want, $1 million profit, you make this $1 million. And then you get x by itself, and you figure out how many you would have to be, how large the contract would have to be, and how many you would make of these covers to make $1 million profit, whatever the goal is. For this chapter, you have a problem in your future where you have to set it up to a break even, which means set it to 0, solve for x. This is a big deal. I want to show you is it the next one? Right here. I had to do this for every customer when I was working for the consulting firm. This was a big deal. Part of our gig was, when we get to our presentation to the owners or the board or whoever is in charge of this company, we want to show them where their break-even point is. Because most companies that brought me in, either they don't have enough profit going, and that's why they're asking for outside help, or they're even losing money. So this chart, revenue always starts at 0. We're starting a fiscal year. Right here today is a new fiscal year. Revenue's at 0. And every one of these we make and sell, revenue goes up. It's a pretty steady line right there because we have a marginal profit on each one. Marginal profit is the revenue price minus that variable cost. We're making how much on each one as a marginal revenue. How much on each one are we making if there's a $2 variable cost on each one? And there's $5 selling price. This camera's recording. I can't edit out this dead silence. What's going on here? $5 selling price. And there's a $2 variable expense. How much is the profit? $3. And that $3 is profit as long as we can cover the 3,000 fixed overhead. Until that 3,000 covers that fixed overhead, we're not breaking even. And that's what's going on here. The moment you start the new year and you're starting to make these, you're in the hole $3,000. And this line goes up $2 for every unit you make. There it goes, $2, $2, $2, all the way up. But this one's going up $5. And right there, what is this? Production volume, but I always have dates on mine. Damn. In a year, this is going through time. And whenever I beat, this is how we start our, making sure we are letting the owners know where their problems are at and why they're not making money, is that here's your break even. In almost every case, their break even was, let me get the line here, up here. And that only maybe, and this would be December usually, like December 10th, December 15th even. And only those last 15 days of your year, because their fiscal was January 1st to December, those last 15 days is the only day you're truly making any profit this company. And then, just go. Now, they don't even realize what's going on. They don't realize how much their overhead is and how much of the cost it occupies based on the current level of sales they're doing of that product to get to cover that overhead. So I know you already know the answer to this because this is so easy. But I'm going to show you the algebra just to make sure. 3,000 plus 2x in parentheses. This is subtracted. So this would be 5x minus the 2x, putting like terms together. That leaves us with 3x. I'm adding 3,000 to both sides equals 0 plus 3,000 is 3,000. I divide both sides by 3. We have to manufacture and sell 1,000 of those Viper covers to break even. There's your break-even point. Now this company looks a little more healthy. It looks like it's about halfway through their fiscal year if this were dates and whatever. Can't remember how many they're selling here, but so this is the sign of a semi-healthy company because they're getting to break even way before the end of the year, and from that point on, every Viper cover they sell is profit. That $3 is going to profit. Where's that 1,000? So if they're usually doing 2,000 a year, their break even's 1,000. How much is the net profit after they break even? If this is 1,000 and they do 2,000, how many's left? 1,000 of them, and then how much are they making off each one after the overhead's covered? $3. So what's the profit? $3 grand. You get it? Because now the $3 goes to profit instead of covering that overhead at that point. So you gotta be able to read the equation. It may ask you for the cost equation. This is a very simple 1-2 problem here. Here it is. Identify the cost equation. And then the next one says use the same information above. Identify the revenue equation. 1 point. All right. Now use the same information above and your answers for the cost and revenue, and calculate the break-even point. So there's what you could expect related to this on a quiz. What are we on? 33. Here is the break-even point can be found by taking 3,000 plus 3x, because back on an earlier slide we took the revenue and put it with that $2 marginal cost. Now we can subtract 3x on both sides. So what do we do? Well, this is negative. We added 3,000 on both sides if you want. Just flip it over, divide by 3. 1,000 is our break-even point. You can find the break-even point now on any story, right? Making sure it's not that hard. It's real simple. I know it's boring and too easy right now, but this is heading, just slowly preparing you for chapters 2, 3, and 4. Trust me, you're going to be happy to go slow. Here's another example. You got form an equation based on the story. This story is all about finding the winning, predicting what you should be starting the bidding at. An auctioneer saying, what should I start the bidding at on this car coming up? So it said, let's put a formula together to determine where to start the bidding. Auctioneer developed a mathematical formula, decided starting bid when the auctioning of the used automobiles coming up for auction. Essentially, the starting bid is 70% of what this formula is predicting as a winning bid. So it starts out with here, it seems to be a formula based on the last 100 cars that came through here that are showing what the winning bid would be. And then the auctioneer says, I want the starting bid to be only 70%. So it says 70% of that. So your whole equation is finding that winning bid, and then just put in parentheses and put times 0.7. Oh, whatever, 70%, right? That's where this is headed. We're going to selling price making 2 deductions. In order to figure out that winning bid, so we can then turn it into a starting bid, we got to go look at 2 deductions. The car's coming up. They're saying, all right, what's the car's original selling price? Now deduct how old the car is, times whatever number of dollar value it goes down for each year of age, and the mileage and whatever amount being used. And it says, the auctioneer says, $800 should be subtracted based on how many years old the car is. Age. 4 years old, 800 times 4. 5 years old, 800 times 5. Subtracted from the original price. Then 2.5 cents. Is that what that says, 2.5 cents? Boy, that's a low cost on mileage. Times however many miles it has is then subtracted also. Those are the 2 deductions. Now what you just heard is 0.025 times something, and then we have 800 times something, right? And they get subtracted from some original price. Just try and throw some variables in here. This is mileage, I'll throw an M. This is year, age, throw an A. I should look and see what the variables are. Age, A. Mileage, M. All right. Original price, P. There's our variable. Now we're going to turn it into an equation. It's not there. Good. Here we go. First of all, the winning bid. It's going to be this original price minus, right here, 2.5 cents times whatever the mileage is, minus 800 times the age. But that's going to give us the winning bid. What do I have to do to it to get the starting bid now? Exactly. So now I'm going to take this whole thing, put times 0.70. That helps there. 70%. And that's how you formulate this equation. Well, it looks like this. Well, the original price minus $800 times however many years old the car is, minus 2.5 cents times however mileage is on it. We're going to take the whole thing and multiply it times 70%. Now use algebra. P times 70%, 0.7p. 800 times 70%, 560. 2.5 cents times 70%, $1.70 or 1.75 cents, or 0.0175 of a dollar. How's that? Now right now, as long as I give you the P, the A, and the M, you can tell me the starting bid now on any car coming up, right? I'm gonna throw one at you. There's a $20,000 car coming up for sale. It's now 4 years old, and it has 60,000 miles on it. Boy, this is a good-looking car. Silver, it's got a sunroof. What? Air-conditioned seats, who's heard of that? What? What are we plugging in here? P, what number? 60,000. So what's my P? Give me something here. Come on, give me something to work with. P. What is it? No, original price. 20,000. Okay, minus, what's next? 4 years. So 4 times what? I'm using the equation up here, by the way. I'm not using this one. I'm using this one. It's 800. So we have, what do I have? How many years old? 4 years times 800 is subtracted. Minus, how many miles? 60,000 miles times 2.5 cents? 0.025. And then I would take the whole thing times 0.70. So I'm doing this one, and I'm just putting the 0.70 on the outside, but you can use this one, and you don't put the 0.70 on the outside. That's fine. Up to you. And that's how you calculate this. Anybody got an answer? What's 4 times 8? 3,200? 2.5 cents times 60, that's, hang on, what's that? 1, 2, 3, so that'd be 250, that's 6, 250, that's only like 1,000, what is it? What's 60,000 times 2.5 cents? Nobody? 12,000?
Yeah.
$12,000? Or 1,200? 12,000?
12 times 4 is 60, isn't it? No, it's not.
$1,500. $1,500? So this is $1,500, is that right? So now we're at 20,000 minus 3,200 minus 1,500. That seems low. You sure? Do I have to do this? Hang on, guys. Yeah, no, 60,000 times.
Oh, I thought that was
60,000 times. 60,000 times 0.025 is only 3,000 or 1,500?
Yeah.
That's it. Okay. All right. Here we go. Now, give me 20,000 minus 3,200 minus 1,500. That's 447. That would be 15,530. 15,530? 15,030?
15300.
15,300. That's our winning bid. We want to start at 0.7. 10% is 15, 40, 45. So we're starting at 11, 10, 9,300. That's all it is. There it is. The starting bid on this car is $10,710. It goes on, and it should come out at $15,003. That seems high in real life. But for this calculation, there you go. This chapter is about you being able to read the story and set up an equation using variables. Being able to write this out and then adding this to it and getting to this point right there. That point. It's about formulating the equation from the story. Yes.
Where did you get 20,000?
I said that was the original, isn't that the original price of the car?
Yeah.
Yeah, the original price of the car is 20,000, and then 4 years old, and then 60,000 miles. I made that one up, it's not mine. I made it up off the top of my head. There is one on the PowerPoint, so let's talk about it. Yeah. Okay, you ready? It's 12,500 original price, it's so unrealistic. What car is that? Suppose a 4-year-old car has 60,000 miles. Now that's a coincidence. Totally, I did this off the top of my head. I had no idea this is 60,000. An original price of 12,500. How old is it? 4 years old. That again is a coincidence. That's the only reason that might have come off the top of my head is because I read this last night to to be prepared today to make sure I reviewed. But 12,500 is the original price. So here's an example of the same thing. This is the equation after everything was multiplied by the 70%. So, original price, 4 years old, 60,000 miles, and starting bid should be 5,460. If I do it this way, you can't tell me what the winning bid is because you got to put the 70% back in. Go ahead.
But the 30% should be for the total thing?
No, that was already multiplied by 70%. Let me go back to the equation so you can see it. This is using this equation where this has been multiplied by 70% already, this has been multiplied by 70% already. I was using this one. The next slide is using that one. So it's already in there. Can we read a story like this auction auto, and if I said, write a cost equation that represents all, the costs involved. If you wouldn't have the original price in there, you would just have, I don't know what I'd say on this one. I'd say write an equation, I guess really, that determines the starting bid. And I'm looking for you to get to this point where you write an equation that looks like this, with whatever variables you want to use. Just define the variables though. P is the starting price, A is the age, M is the amount of mileage, and then you write this equation using the variables. If you want to use X, Y, and Z, I'm happy with that. Whatever variables you use, you just got to be able to write the equation from the story. Okay. I posted this. This is a break-even analysis right here, and I filled it in with that story. Hey, I forgot the story. What are they making this? 3,000 overhead. I forgot. $2 off each one. Oh yeah, thank you. Cell phone cases. They're going to get cell phone cases to set up this whole thing to make the cell phone cases. $3,000 overhead. On this Excel that I posted, there's our fixed cost of the $3,000. Then variable cost per unit. Every case we make, the story said, we're going to take on labor and parts or materials of $2 for each case. So there's our variable cost. Selling price. The story said we're going to sell each one of these for $5, right? Enter that in there. You leave production 0, and then you got to tell Excel what is it you're trying to find. How much revenue is it you want to find out? How many you need to make to meet that revenue? You put a 0 here for break even. Then you follow these steps. You ready? Let's pretend. Right now we don't have anything there for production. The number we're looking for is to get us to 0 revenue, which is break even. We know the answer is, but let's do it by using Excel. Select the data tab at the top of the ribbon. What is data?
The green one.
Right there? Okay. Select the what if analysis, and when you go to yours, you're going to go, oh, look at that. There's no what if analysis. Oh, there it is. Check it. You may have to install it. It's an add-on. Email me if that's, or just go install what if analysis add-on. It will show you step by step how to install it. Same with this data analysis over here in the solver. Some older Excels don't have it there automatically. You have to install it. But you just do a quick search. Select goal seek in the what if analysis. So we go to what if, select goal seek, which is right here. When the goal seek dialog box appears, enter the total profit loss cell location. Total profit loss cell location is D17. I think it's already in there for me. D17. Then it says enter a 0 for the value. 0 meaning you want to get it D17 to what value? Profit loss of a break even. And changing what cell to find that break even. Right there, we want to know how many to produce to get to break even, so that's D11. Let's talk about this one more time. I'll make sure you get it. When this dialog box opens up, follow the little instructions right here where it says, what cell are you setting? And I said, enter the profit and loss cell as the location as the set cell, which means this is the one it's going to look at to determine what you're trying to accomplish. And we are going to set that as we want that to be what? What value do you want that to be? We want it to be 0. We want to see what the break even is. Then by changing what? We want Excel to change that number to whatever it is, however many it is we have to make to get that to a 0. And then you just click OK right here. Now watch the numbers. Watch how fast they go. What did I just do? Click on something. I changed a number, didn't I? All right, here we go. What if goal C, D17. We want this to be D17. We want the value to be 0. What? Do I have it okay? Changing D11, right? Now watch the numbers change. Look how fast. There it is. 1,000. What we got to make to get that to 0. Hey, you know what? I want to do it again, but this time I want to make some real profit. Let's see. Well, we have to sell to get a real profit. Still D. This is supposed to be D17. This we want $500,000 profit. $500,000, right? Does that sound fair? Changing what? Well, that'll be D11. All right, here we go. $500,000 we got to sell how many? You already know it. 167,667 cases, and we're $1 million in the green. We have cash meaning. We'll be cash heavy. This is a small business. Make it a little home thing. See how it works? Everybody see how this works? Instructions are on there. Play with it a little because if this is on your quiz, it will say, look, it will be like a picture like this. It'll say, and these will be blank. It'll say, wait, let me get to where it will say, what should you enter on your goal sheet? Hang on. Right here. It'll look like this, but nothing will be there. What should be entered on that goal sheet box for the set cell based on the picture of the spreadsheet? And you got to say, you'll be able to see the numbers by the way. And you're going to say D, whatever number this is, in that picture. And then the next question may say, what do you set if you're trying to find the break even, what would you set to value to? You got to look at your notes and say, oh, 0. Okay? Well, it should be the third one. So if this is not a quiz, that's the kind of question you should expect. Asking you how you use that. All right. We got a little bit more for today. Okay, that's it as far as formulating equations and break-even analysis and break-even. Now we're going to the parts of linear programming. Equation.
Will we ever have to look at demand dropping off or anything like that? Or
What do you mean dropping off? Where, like in reality, demand may not be what we've been told instead.
Yeah.
We're not going to go that far.
Okay.
We're all about how to calculate if demand is what's being told.
All right.
And what to expect. So yeah, that's right, that could happen. The economy is a big reason that happens to a lot of companies. They did all their budgets and all their forecasting based on a certain amount of demand that they've had in the past in the last few years, but economic changes, at the beginning of 2009, everybody had to redo everything because no one had an idea what demand would be after the financial crash at the end of 2008. And everybody's business slowed down. All right. So now we're going to slide. By the way, here's many of the subjects you're going to be studying that you're going to learn in this class. You're being introduced to. Now, we're not going to do integer linear programming. We're just doing the original linear programming. Then we're doing PERT CPM. We're doing that. We're doing inventory models. We already did waiting line. It says walking line, but it's really waiting line models we're doing in Chapter 11. Simulation, Chapter 12. Forecasting, Chapter 15. Decision analysis, we already did Chapter 13, only introduced you to it. There's a lot more to decision analysis. I kept it easy so that you guys didn't disappear. Distribution and network models we're doing in this class. So we're covering a lot of this. But we're going to slide 13. Going back. Okay. When we finally get to where we're given something, not jumping around because I want you to see something. Here is the easiest linear programming problem you'll ever see in college, in your life. This is it. This is the easiest one you'll ever see. You can't get easier than this. With linear programming, you're going to be told a story. And at the end of the story, you've got to say, for this first quiz, I'm going to tell you the decision variables and what they mean. After the first quiz, you will always have to come up with what are the decisions that have to be made and set them to variables and define them. So as we read this story, you're going to realize, oh, we're trying to decide, put yourself as a manager, we're trying to decide how much blanky blank we should order from one supplier and how much blanky blank we should order from another supplier. Now in real life, there's 50 decisions to be made and 100 constraints. So this is very micro. And here there's only 2 decisions to be made. How many units of whatever this is, how many units of whatever this is from 2 different suppliers. What's the optimal order we should put in? And as I'm reading this, you're going to realize you can do this right off the top of your head. You can tell me right now how many, at the end of reading this, you'll be able to tell me how many to order from each one, because one will save you money. It'll be easy. That's what managing a company is about, keeping your costs as low as possible. But we're heading to where they don't pop out like that. It's not that easy. So take this to heart as to the process you're learning, so you can apply the process to these much bigger problems coming up. A candy manufacturer buys sugar for candy from 2 suppliers. One calls sugar supplier 1, the other one's called sugar supplier 2. What? I think it's wait.
I like the names.
The candy manufacturer needs at least 55,000 units of sugar. I didn't put pounds. I don't want anybody to get confused or whatever it is, just units, whatever it represents. And now I want to mention something right there. That sentence you just heard, the candy manufacturer needs at least 55,000 units of sugar, is what's called a constraint. It's a limitation. It's something you have to adhere to. Whatever decisions you make, you better not order less than 55,000 units. So when it comes to linear programming, you got to write an equation that's telling the computer, hey, don't order less than 55,000 units. You order 55,000 units or more, because they need at least that much, right? That's an equation that we're going to talk about. You've got to be able to write. Next question. The next sentence says, supplier 1 can supply up to 36,000 units. That is a constraint. Let me give you another word for constraint. When you read something that sounds like a limitation, whether it be a good limitation or a bad limitation, that's a constraint. And somehow you're going to write a mathematical formula that represents however many of, if the decision is how many to order from supplier 1, if that's one of our decisions, however many we order, it's got to be less than equal to 36,000. Well, these equations are almost all using less than equal, greater than equal, or equal. And every constraint, I guess I want to say constraint, and I'm never going to say it. One of these 3. Right? So when you see the words like at least 55,000, there's no way that could be an equal. That's either a less than equal or greater than equal. At least 55,000 means if you're writing this out as an equation, you're telling the computer however many we buy from supplier 1, however many we buy from supplier 2, give me the equation. Less than equal or greater than equal, 55,000.
Greater than equal.
Greater than equal, because we have to buy at least 55,000. When you add up how many you're buying from supplier 1 and however many units you're buying from supplier 2, they better add up to 55,000 or more. Greater than equal. You just, that's that one. There's the right-hand side right there. Greater than equal, 55,000. There's the right-hand side of an equation. That's 7. Let's do this one. Supplier 1 can supply up to 36,000. There's no way that's equal 36,000. Is it less than equal, greater than equal 36,000? I heard it, but I can't do it. That's it. You now you're trying to say, well, hang on. Okay. If you do put greater than, though, you're trying to say, hey, we're going to order from supplier 1, and we're either ordering 36,000 or more, but they don't have more than 36,000. They have only up to 36,000 available for you. So there's the right-hand side of that sentence right there. Less than equal to, or I forgot, how many? 30 what? 36,000 units. There's a second limitation. Look at this sentence. Supplier 2 can supply up to 26,000 units. Give me the right-hand side of that sentence right there. Less than equal, greater than equal, or equal? Less than equal, less than, come on. Less than equal to, how many? 26,000 units. You have three right-hand sides of three different equations that were represented by these limitations that are in the story right there. Let me keep reading. How are we doing at time? We're doing fine. The price per unit of supplier one sugar is $5. The price per unit of sugar 2 is $4.50. Now, as a manager, you're about to tell me that you should be ordering more from supplier 1 or supplier 2. You tell me. Because it's 50 cents less for every unit we buy. Matter of fact, supplier 2, we want all you can give us, but they can't fulfill the order. Right now, many of you in this room right now can tell me exactly how many we need to order from supplier 2, and then how many we need to order from supplier 1, right? It's that easy. And you would never use linear programming to solve this. It's so easy. But we're heading to where you are no way going to be able to look at this and come up with a solution. And you have to go through this process and get it worked out in equations. And then you plug the equations in, and that tells you exactly what to buy from each supplier. That's the optimal amount in order to fulfill some kind of objective that you're trying to fulfill. That's where we're at, objective function. It's an equation that represents what you're trying to do. What's the ultimate objective of this process? Let me get to the sentence. Write the objective function and the constraint to solve how much sugar should be purchased from each supplier. It's literally telling you what the decisions are. You're writing equations, objective function and constraints, that will determine how much sugar, how many units, from purchase from each supplier while, now this is the sentence that's all about the objective function, while keeping the cost as low as possible. That's your objective. The decision, how much to buy, the objective, keep our costs as low as possible. And that's why I said to you, who would you rather buy from? That's what the computer's going to do. It's going to say, oh, you told me the objective is, by the way, every single objective function this whole semester ever has to have one of these two words in front of it. I'm abbreviating, so use abbreviation. Maximize or minimize. Maximize or minimize. You're telling the computer you want something to be max or you want something to be min. Every objective of every linear programming problem has the objective function starts with one of these words, and then it's an equation. And it's not equal to, greater than equal, or less than equal to anything. The equal part is that you're either telling it to max or min. And you want it to be as large as possible or small as possible. Our objective is this. Do you think our objective function is going to be a max or a min? Min. As it says, keeping your cost as low as possible. Here's the beginning of our objective function right there, and then there's going to be an equation next to it. What? Now, let's pretend we don't know the decision. And we're saying, we have all this, but we don't have this yet. And the first question you should be saying to yourself is, how many decisions have to be made here? If this is my project, how many decisions is it that I'm trying to accomplish? And there's two. And it's all about how many units should I buy from supplier 1, how many units should I buy from supplier 2. There's the decisions. Once you identify them in your head, you write them down on paper and make them equal to some variable, any variable you want. I don't care. Everybody has different variables. I'm looking to see your process, your logic behind it. I use X. It is the number of units from supplier 1. Don't get confused. That's the number of units, not how much dollar amount to spend on supplier 1. That's not what this is. It's how many. Decision 2. How many units should I supply from supplier 2? It doesn't say how much I should only spend, how much to spend on supplier 2. It's how many units. But the objective function is not about keeping the number of units as low as possible. The objective function is about keeping our cost as low as possible. We got to look at these variables and we got to somehow turn them into representing cost. So if I went ahead and said I'm going to buy 10 here and 10 here, I want you to tell me, how would I figure out how much that's going to cost me? How much would it cost me if I buy 10 from supplier 1? How much will it cost me?
Multiply the price by 8 times.
The price is given. And so if the objective is to keep our cost $5 and $4 times however many we're going to order as low as possible, I'm going to convert my variables X and Y into representing the cost, because I want to keep my cost as low as possible. So I have the first one $5 or $4. The first one, supplier one, is that $5? $5 times, is it X? Yeah. X1 or X? X. Plus, however many units I'm going to order from supplier 2 at $4.50?
Yeah.
$4.50 times Y?
Yep.
There's the objective function. I took the sentence, keeping your cost as low as possible as being the objective. I used the word max and min, and then I formulated an equation with the variables that I designated as the number of units, Now, no matter how much I'm emphasizing this, someone's not going to watch the video, and they were absent today, but they're going to kind of go through the book, it's open book, and open PowerPoint, but they're going to put minimize X plus Y. But X plus Y is not representing how much we're spending. X plus Y is representing how many we're ordering. That's not what we're minimizing. This is all about minimizing how much we're spending. So you've got to take the variables and convert it to the amount you're spending. That's why we're multiplying it by the individual prices for each one. Let's go back to that constraint. Wait, I want to go off objective function because this is the point I wanted to give you the book definition. What slide did I say, 13? The objective function is a mathematical expression that describes the problem's objective, such as maybe maximizing profit or minimizing cost. Here's an example. Consider a simple production problem. Suppose X denotes, where's that sign sheet? Oh, you gotta be kidding me. Hey, don't sign this time, print. Some of you actually not read what you wrote. Just print. You don't need to sign. I remember at the top I'm now calling it a print-in sheet. Alright? Alright. You know how long it took me to figure out who is that? Who is that? Anyway, it took me a while to figure out that some of you now are just writing your name next to the printed ones. They were so far apart, I thought, God, this class is packed. I didn't realize it's the same people on some of them. Here's an example of an objective function. Another one, suppose X denotes the number of units produced and sold each week. So the decision is, we're trying to decide how many we should produce for the week. And the firm's objective is to maximize the total weekly profit. But the X doesn't represent how much we're going to make, it's how many we're going to make. So we take the $10 profit on each unit and write it as an objective function, putting it with the variable. However many we're going to make, we're making $10 profit on each one. What word would be in front of this if this is $10 profit on each one and this represents how many we're going to make? What word would be in front of it if this were the objective function? Max. Because the objective is probably to maximize the profit, and we're making $10 each one. You're telling the computer, we have all these limitations, stay within them, but keep focusing on here to make sure, in this case, we keep our cost as low as possible. Just like you decided you're going to buy as many as you can at $4.50 before you have to start spending $5 for each one, the computer is doing the same thing, but it's also making sure it doesn't violate any of these rules that we're giving it. And that's a lot of information. I want to make sure we have stuff left over for Tuesday. So, we'll have a good week.